Hello everyone, my name is Amit Kumar and I currently work for Future Solutions. The purpose of this video series is to get started with big data and NoSQL concepts, and I'll demonstrate you an application that I've been developing in a subset of my free time. So let me just flip to my GitHub account. Okay, this application is built on ASP.NET MVC 4. It's using the all popular NoSQL database MongoDB, a search engine, a distributed caching product such as Redis, and a messaging middleware RabbitMQ. Alright, so before we get into this application, let's just get a glimpse of what NoSQL is, why is it required, and what makes it such a hot favorite nowadays. Alright, so a NoSQL database is basically a distributed storage system. That basically means that you can spread your data on multiple machines, which are called nodes, and all of them collectively behave as a single database. And why it is required is because of performance. Okay, when your data is low, your data is small, let's say, and then performance is not a consideration, or it's not a bottleneck, because everything loads up pretty quickly as the data is quite small. But when the data grows big, that means you have big data and big users, say, then the performance gets a hampering. So performance means a higher or greater read and write throughput when the data grows big and your number of concurrent users also grow big. And that's what is basically known as scalability. Let's just go to understand this better, let's just go to, say, any of the NoSQL products website. Well, all of them come with tons of documentation. So you go to couchbase.com, you click why NoSQL is required. So what basically is driving NoSQL is bigger number of users, big data. Okay, so big data could actually mean a different thing from one organization to another one. Say for a smaller business, a couple of terabytes of data could be huge, but for a bigger business, even, say, hundreds of terabytes of data may not be huge, because that's how their business runs. Third one is obviously Internet of Things. Internet of Things means, say, your application is being accessed from a wide range of devices. Say people access it from desktop computers, laptops, mobile phones, iPads, and tablets as well. So your user base is huge, and since people are accessing it from so many devices, your data also grows every day. So that's what is Internet of Things, and it is driving the NoSQL movement crazy actually. Next is cloud computing. Alright, so this is how you support large number of users, and you basically scale up or scale down depending on the kind of traffic you get. So most of the cloud providers provide you with what is known as commodity hardware. Let's take a look at what could actually be a commodity hardware. Actually, a couple of my friends were asking me what could be the specification for a commodity hardware. So commodity hardware means you have 16 to 32 GB of memory, at least a terabyte of hard disk, and a couple of quad core processors, a gigabit of Ethernet card, and most important thing is it is quite cheap. It will obviously come between $1,000 to $2,000. So that's what cloud providers basically provide you. They provide you with commodity hardware so that you scale horizontally. So when it comes to scaling, you have two choices. Either you scale up, that's called vertically, and this is what mostly happens with relational databases, that as your data grows or your load grows, you purchase a better server and you put your database onto that. But NoSQL takes a different approach. It takes the approach of horizontally scaling, that is scaling out, and that's where it shines. I mean, so its basic traits are, say, replication and sharding. So sharding means that you spread your data across multiple machines or nodes, and replication is you replicate your data for failover situations. Alright, so moving next, all big data solutions, or what are known as distributed storage systems, are driven by something known as CAP theorem. So internet is our friend here. Let's just type CAP theorem and see what it means. So CAP basically stands for consistency, availability, and partition tolerance. You can just go to Google Images and say CAP theorem. Alright, so the very first image here says, what does consistency mean? Consistency is that all of your clients see the same data at any given moment. Then comes availability. Say availability means, say one of your node goes down, so but your application should still be able to function through your application servers. That's what availability means. And partition tolerance, this basically caters to network partitions actually. Let's say you have two nodes, node A and B, and both of them are up and running, but the communication between them has broken. So that means sync between node A and B does not happen. So you have two choices here. What you do is, either you take your application down and say that I am maintaining strong consistency, else you continue to function and tell your users that what you see right now could be somewhat stale data, but as soon as we resolve our network issues, we'll sync everything up and be consistent. Okay, moving next is, okay, this is for production purposes, basically say better hardware or file systems. Okay, I'm not speaking about Windows here. I'm speaking about Linux file system, say XFS or B-tree file system. Say, let me put it this way. These file systems, say extensible file systems or B-tree file systems, are much better in writing or reading data from the disk. So this is basically a production use case scenario which helps in attaining better performance. Next comes, okay, what are different possible types of NoSQL databases? So NoSQL databases can be categorized into 4 types. The first one and the simplest one being key value pairs. Examples are, I mean, we must have seen, most of us must have seen Redis or Memcached in our projects, right? So this is basically a key value pair, where this is something like you have, say in .NET or Java, you have hash tables or hash maps. So you have a unique key for each object and a value corresponding to that key. So value could actually be a complex object graph as well, and these ones are highly performant. Obviously you look up by a key and it gets you the result. Another example could be, say, React here. Alright, document, the second category is about document oriented database. It is those document oriented databases actually store data in JSON format. Examples could be MongoDB, CouchDB, Couchbase, and a few others. Then there are third category is about columnar or column family databases. Say in a relational database you store data in rows, whereas in a column family database such as Cassandra or HBase, data is stored in columns. So that's what makes it a perfect fit for running aggregates actually. Then the third one, or not the third one, the last one is a graph database. Okay, graph database is somewhat different to other databases that you might have seen. It consists of a concept called edges and vertices. So in the same place, let's just type graph database and just get a basic understanding of what it could be. Okay, so what happens here is every entity is treated as a vertex. Say Alice, Bob, or this group are entities. Okay, so Alice, all traits of Alice, say his ID, name, age, or whatever, salary, let's say, are stored in the vertex, and relationships are stored as edges. Say Alice knows Bob, then Alice is a member of a group which is chess. This sort of database can actually help you where your business domain structure is complex, and this is mostly used in making recommendations. I mean, you would have seen on Amazon or Facebook, say in Amazon, when you open up any product, let's just go to amazon.com. I just open any product, say Java book. Alright, so these graph databases are actually useful in making these recommendations, like who those customers who bought this Java book also bought other similar Java books, and this is used, a graph database is used for tackling complex business scenarios as well. Alright, so in the next video we'll see this application running. Thanks for watching.